Okay, so this is going to be a review of the Chapter 2 exam, Question 2. And so let's go ahead and get started. In this question, you were given a graph of f of x that is made up of line segments and individual points. And we have 4 questions about it. We're supposed to determine the value of the limit of f of x as x approaches 3. We're supposed to justify our answer, and if the limit does not exist, we have to explain why. We need to identify the type of discontinuity at x equals 7 and give reasons. We have an equation for the function for x greater than 9, and we need to find the value of k such that f of x will be continuous at x equals 9. And then part D is we need to determine the continuity of f of x at x equals -5 and explain our reasoning. All right, so here's part A. Determine the value of f of x, the limit of f of x as x approaches 3. So first thing we got to do is look at what's happening at x approaches 3. And to find a limit, we should look from the left side. And if I look at the left side of this graph at x equals 3, I see that I'm approaching a y value of 2. And so therefore I know that the limit of f of x as x approaches 3 from the left is 2. And I want to report that with the proper notation and indicate that value. The next, if I can do that, that's 1 point. Knowing that you should look for the limit from the left is part of this question, and then actually finding the value is another part of this. So if you can do that and write it down correctly, that's 1 point. Now we got to do the same thing from the right side. So if I look at this function to the right of x equals 3, I can see that this function is approaching a y value of 0. And so I got to write down that the limit of f of x as x approaches 3 from the right is 0, and that is another point. Finding the limit from the left is 1, finding the limit from the right is the other, and I still haven't answered the question because I now have to compare the limit on the left side and the right side, and what we notice is that the limit from the left does not equal the limit from the right, and that means that the limit does not exist. That's the definition of a limit not existing. And so now I've answered the question. I have determined the value of the limit, and that is the conclusion, and we get a point for that. So the whole thing is 3 points, 1 for the limit from the left, 1 for the limit from the right, and 1 for the answer. Now, one thing you got to be careful about in this problem is being specific enough. So, for instance, you could leave out the part about the limit from the left and the limit from the right, and you could just say that the limit from the left doesn't equal the limit from the right without actually identifying the numbers. And this is not good enough. This is going to get you 1 point for making the right conclusion. You are correct if you've written this down. The limit does not exist. And you can tell that from the graph because the limit from the left and the limit from the right don't equal each other. And this is a true statement. And it's worth 1 point. However, one thing you got to do on an AP calculus question is you have to connect the particulars of this problem to the general ideas of calculus. So this statement, the way it's written right now, is just the rule for limits existing. It says that the limit from the left does not equal the limit from the right. That means the limit does not exist. So you're just quoting a definition. And you never get points for quoting the definition. You have to have the specific instance of that definition in this problem. So you need to get specific and tell me that the limit of f of x at x equals approaches 3 from the right or from the left equals 2. We're specific to the x coordinate, we're specific to the y coordinate. This is exactly the answer for this problem. It's not the answer for other problems. And likewise, the limit from the right of f of x as x approaches 3 from the right equals 0. So you have to have those specific values to get all the points. Okay, in part B, we are supposed to identify the type of discontinuity at x equals 7. So I got to go looking for x equals 7, and I see at that point that I've got an open hole in the graph. And so I know this is discontinuous, and the question is which type of discontinuity is that? And the thing I need to consider is, does the limit exist? And so I can visually see that the limit from the left and the limit from the right are both approaching the same point. So the limit exists, it's -2. However, there is the point on the function at x equals 7 is not at -2, it's at 1. And so this is a removable discontinuity, and the reason is because the limit equals -2, but the value of the function equals 1. They are not equal to each other, and that's the definition of a removable discontinuity, and that's worth 1 point. There are some other calculus books that will call this a point discontinuity. So if you use that word, that would be fine too, but it's a removable discontinuity. It is not a jump, it is removable. So there are two questions basically in this problem. One is what type of discontinuity is it, and the other is what's the reason. So identifying it as removable gets you 1 point, and then the reason is the second point. So, and the reason, the correct reason is that the limit is -2, but the value of the function is 1. If you said something sort of nebulous and not using the correct vocabulary, things like there's a point, but the point is not on the line does not equal the point, and there's things like this that people will say in trying to describe this when they don't have the vocabulary correct. Part of the question is the vocabulary and the notation. So the way to answer this question is to give evidence that the limit of f of x as x approaches 7 is -2, but f of 7 equals 1. All right, so part C gives us an equation for f of x for x greater than 9. So that's to the right of the graph that we're provided. And this equation has a k in it, so k divided by x minus 8. And we want to find the value of k such that f of x is continuous when x equals 9. So if I look at the graph, I can see that from the left, as x approaches 9 from the left, the limit of this function looks like -3. And there's a solid point at -3, so the limit equals the function. And so there's only a left side, there's no right side there, so we could call this left continuous. So in order to make the function continuous from both directions at 9, I have to have this equation coming in from the right has got to equal 9 also. So the limit from the left and the limit from the right have got to be equal to each other at that point. They both got to be equal to -3. So we can write that by saying, okay, the limit from the left has got to equal the limit from the right. So k over x minus 8 is the limit from the right, and that's got to equal the limit from the left. Now, if we now substitute in the particulars, that means that k over 9 minus 8 equals -3. And this is now an equation that we can solve for k, and it turns out that k is 45. And that's the answer to the problem. And this is all worth 1 point. This is a pretty familiar question. We saw it several times in the unit. It was on a couple of different assignments. So hopefully this was one you could recognize, and then it's a pretty simple piece of algebra to solve that, to come up with that answer. So this is either right or wrong. Either you have the right answer or you don't. Okay, now part D, we are supposed to determine the continuity at x equals -5. So we want to go look in the graph at what's going on when x equals -5. And I can visually tell right now this is continuous. It looks continuous. But I got to explain the reasoning. So if you just answer that, oh, this is continuous, you're not going to get all the points because you haven't explained your reasoning. So what are the reasons that are required to make a graph continuous? You got to look at the limit. Does the limit exist? And I can see the limit from the left equals -2. The limit from the right equals -2. And therefore, the limit of f of x as x approaches -5 equals -2. That's the first piece about continuity. You got to know that the limit exists. And so if you identify that this limit exists, that's worth 1 point. The second thing I need to know is what's the value of the function. And so when I look at the graph, I can see a solid dot at x equals -5, y equals -2. So f of -5 equals -2. That gets you the second point because you've identified the value of the function at -5. If you stop now, you haven't answered the question. You've got all the pieces and you've got some partial credit. You've got a couple of points, but you haven't actually answered the question. You haven't determined the continuity yet. To nail this down and finish it off, you have to say that the limit equals the function, either in words or in symbols like this, and therefore f of x is continuous at x equals -5. And that's the third point. Okay, so if you go to the Schoology folder for today, Friday, October 23rd, you should be able to find also a PDF file that has all the solutions to all of the variations of this problem that were used on this test. So you can see what the different numbers are. And you can see where the points were given and where they were not. So you should be able to go look that up in Schoology now and review your problem and see um, how yours went. If you got any questions, you can go ahead and email me. Remember, there is a problem set 3.3 that's due Friday by 11:59 p.m. If you haven't worked on that yet, you should. And again, email me with questions throughout the day about that, and I will answer them the best I can. Good luck with all of that, and I will talk to you later.